This video is about the right prism, where we are given the volume, and in part A we are asked to find L. L is the length of the right prism. Now we need a formula that involves L. Now both the volume and the lateral surface area involves L. However, we know the volume. V, the formula first. V is equal to the area of the base, let's call it AB, multiplied by L. L is the length of the prism, and AB is the area of the base. This one or this one, it's the same. So let's deal with the area AB of the base, which looks like this. Let's redraw it here. So this is 90 degrees, this is 90 degrees, therefore these are parallel, 10 centimeters, 5 centimeters, and 10 centimeters here, and this is a trapezoid. Now the area of trapezoid AB, if we call this H, this A, and this one B, the area of the trapezoid, it's 1/2 A plus B multiplied by H. So let's substitute the values to find AB equal to 1/2. A is equal to 10, this side here. B, the length of the side that is parallel to A, which is 5. And H is the height of the trapezoid, and it is 10. Now this gives 75 centimeter squared, because the length are given in centimeters. Good. So now what we do, we go back to our formula for the giving the volume. So V, the volume, is known. It's 1,500. It's equal to AB. AB is equal to 75 multiplied by L, and therefore L is equal to 1,500 by 75, and that gives 20 centimeters. So we found the length L, 20 centimeters. So we have answered part A. So this is all part A. Now let's go to part B. Now in part B we are asked to find the total surface area, lateral, and the bases of the prism. Now the prism has got two bases, one here and one here, and we have already found the area of one of them. So let's put it again here. The area of one base is 75 centimeter squared. Now the area of the lateral surface, these 4 rectangles here, 1, 2, 3, and then 4 here, it can be calculated in 2 different ways. We can go and find the area of each rectangle, or what we can do is take the perimeter of one base and multiply it by L. So maybe taking the perimeter is the easiest one. However, we need to find this side here. So let's draw the base again here. So we need to find this side here, which we call H. This is 5, this is 10, and this is 10. Now let's draw a broken line here that makes 90 degrees. So we have already 90 degrees here. So this is a rectangle. This here is a rectangle. Therefore, this is 5. And this, all this is 10. 10 minus 5. So this gives me 5. And this gives me 10. Now let's concentrate on this triangle, which is a right triangle, and find H using the Pythagorean theorem. h square, the hypotenuse square, is the sum of the square of the side 5 and then 10. 5 square and then 10 square. Now h square, we simplify here 125, and h, to find h, take the square root of this side, the square root of this side. Now let's leave it like this. So the perimeter, let's call it P, of the base, perimeter of the base, this base here, it's 10 plus 10 plus 5 plus h. So it's 10 plus 10 plus 5 plus h, the square root of 125. And the A, let's call it A lateral. Let's explain it again. The lateral, the lateral surface is made up of this rectangle, this rectangle, this rectangle, and this rectangle here. So we call it AL, yeah? So it's going to be PB, the perimeter of the base, multiplied by L. Now this gives me 25 plus square root 125 multiplied by L, 20. So now the total area, A total, remember, it's going to be the two bases. Let's go back. One base here, and then the lateral surface which we found. Now AB 75 and then twice. So let's put the formula. So it's the area of the two bases plus the area of the lateral area, the lateral surface. That gives me 2 times 75 plus this here, 25 plus square root 125, and all this multiplied by 20. Now, using a calculator to approximate the square root and all the sum, we get 873.6 centimeter squared. This has been rounded to the nearest tenth of a unit. Now, in part C, we need to find the cost of the material needed to make the this light prism. Now, the material, it costs $200 per meter squared. Now, the area we have, it's in centimeter squared. So we need to find, to make a conversion first. So we know that 1 meter is 100 centimeter. Now we square both sides, yeah, because we need squares. Centimeter, and then we square here. Now let's simplify. 1 square, it's 1. And meter square, it's meter square. 100 to the power 2, that's 100 multiplied by 100, and that's 10,000. And then the centimeter is centimeter squared. Now we need to find 1 centimeter equal what in, 1 centimeter squared is what in meters squared. So what we do, we divide by 10,000 here, 10,000 here. And this tells me that 1 centimeter, okay, when you simplify here, you are left with 1 centimeter equal to 1 over 10,000 meter squared. So what we need to do now is to go and find this area converted into meter squared, and that's very simple. 873.6 centimeters squared is equal to 873.6. Now we replace centimeter by what? By 1 over 10,000 meter squared. And when we do the calculation here, when the calculation is done, so we divide this by 10,000, that will be moving the decimal point 4 positions, and then we get this. So this is our area in meters squared. Now the cost is 200 per meter square, so the cost of the right prism will be equal to the area meter squared, and then we multiply by the cost of each meter. This is the $200 per meter. You simplify the meters and you are left with dollars. Cost is about 17.5 dollars, so $17.50.